design, the classic LCA takes too much time. The designer wants a sustainable product design, but cannot invest a lot of time in the investigation of all its materials, parts, components, energy used during usage or in production. The designer just wants to know if the sustainable product is better than a competitor. They want to make design decisions in a fast way, and there's no time for thorough investigation on the cost or the impact on the environment. The Track LCA is a solution to this. Databases exist to find the cost or the impact on the environment. You might not come up with the exact figures, but you can reach about 80% accuracy with the use of databases. So this is a good option for the designer. It can help you make design decisions efficiently and end up with a sustainable design at the end of your design project.
In the fast track method, you skip the impact assessment phase and you use standardized information.
Through the use of databases, like add-ons in SolidWorks or existing databases. I will share one also on Blackboard. There are kits, there are paid databases, there's a whole range of options available for making the fast track lifecycle assessment. You will reach in the end about 80% of accuracy, so that's quite high accuracy, and it is much more efficient. I will explain more about that later, but for now I will dive into the different applications of fast track lifecycle assessment in the design process. Fast track lifecycle assessment method can be used for the same purposes as a classic lifecycle assessment. It can be used for investigation of the impact, for strategic design decisions, and for claims or certification. But also it can be used for design decisions, for benchmarking. For example, in the concepting phase you can compare different concepts with one another and see which one is more sustainable. With benchmarking you can compare your product ideas with the ideas of a competitor. And the fast track LCA can be used in any stage of the design process. It can be used in the analysis stage, or ideation, or concepting, or even in materialization. And you will reach about 80% of accuracy in 20% of the time or effort in comparison with classic LCA.
So you could do a benchmark in the early stages of your design project with competitor products. So you can analyze how sustainable competitor products are. You do a disassembly of the competitor product and you weigh every component, and you define or identify the materials of every component, and from that you can maybe estimate how it's produced and how much energy it costs to make it. You can estimate how much energy it uses during usage, etc. And if you do this for a couple of products, you can create an overview of where there is a gap in the market and where you could create a new product. And also you can do fast track analysis in the conceptualization phase. You could start with an analysis of an old product or a competitor product. And if you know all the impact of the components, you can start to improve and conceptualize new ideas that are more sustainable. And if you have different concepts, you could do a fast track lifecycle assessment for each concept, and then you can compare them and choose the most sustainable one. And there are different ways to go about this. There are 4 types of sources that you can use. There are free databases, there are add-ons in SolidWorks, there's software that you can pay for, and there are free starter kits with a limited amount of information. And in these databases they make use, for example, with measures, and eco-cost is one of them, and that is a measure to express the amount of environmental burden of a product on the basis of prevention of that burden, so the cost that it needs to prevent impact on the environment, negative impact. For example, for every 1,000 kilo of CO2 emitted, you would need 135 euros that you need to invest in windmills or other energy systems. That will result in a 35% reduction of CO2 emissions. To make this more clear, we can look at an example, the ceramic mug versus a plastic coffee cup. The goal is to find the most sustainable material for the coffee cup. If you look at the scope, there's the coffee cup. We can look at production, transport, use, cleaning and recycling. And the functional unit would be 4 cups of coffee per day, 5 days per week for 5 years. What we then exclude is the dishwasher, the production of the dishwasher, the labeling on the cup, the transport from the retailer to the office and any packaging. And so we have defined the scope. Then you look within this scope where it's made of. What is the material, how much material, is there transportation, is there cleaning, recycling, etc. Then you look up the eco costs for each element. And then you calculate the total costs for the 2 versions, for the mug and for the cup. And then you can make a conclusion. For example, you need 70 polystyrene cups for 1 mug. What we did not take into account yet was the cleaning of the mug. If you do that and you assume it would be once a day, it means that after 2.5 years the mug is better. So make sure you have an accurate scope when you compare the 2 things. So comparing these 2 things, it will cost you about 2 hours. You will get quick results and you could do it in any time of your project. And the most important thing is the interpretation of your data. What do you want to get out of it? And you should have a scope that fits that. So to summarize, the fast track LCA consists of 3 phases, the goal and scope definition, the inventory phase of the information from the databases and the interpretation.